Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. So here's the problem. This comes from the math curriculum in the UK, and basically some algebra, a little bit of trigonometry type of concepts here. And it says that a kite ABCD, let's go ahead and start with that. A kite ABCD has congruent consecutive sides, AB and AD, BC and CD. Okay, I'll draw this out in a second. We also know that the diagonal length is 40 centimeters, and we know two angles, 100 degrees and 50 degrees. Okay, now our task today is to solve these four questions. A, draw the diagram. B, find one of the missing side lengths. Okay, we'll get to that. C, add the second diagonal and label it. And D, find the length of diagonal BD. All right, so let's go ahead and take a look and draw this out. So here's our kite drawn out, and from the given information we know that these two sides, AD and BD and BA, are congruent, and these other sides are congruent, and that of course is what makes it a kite. Okay, so we know the length of this long diagonal AC is 40 centimeters. We know this angle in here is 50, and we know this angle out here is 100. Now just, although it doesn't affect our question here, if this angle is 100, this angle is also 100, and if this little angle here is 50, then this little angle here is 50. Okay, all the angles match up, and that diagonal actually bisects or splits evenly those angles up there at A and C. Okay, it's just the properties of what you call an isosceles kite. Now, knowing what we know about triangles, and I'm just going to kind of color this in here, let's go ahead and just look at one of these triangles because they're actually congruent triangles here. I have a 50-degree angle, a 100-degree angle, and yes, we can figure out that that angle is 30 degrees. Okay, now that might come in later, a little bit handy, but basically we're going to take the information we know, and we have to figure out this side right here, BC. Okay, that's our missing side. All right, well, what comes out of this is an application for the Law of Sines. Here it is. The Law of Sine says that, and this applies to every non-right triangle situation, that the sine of one angle compared to the length of the opposite side, so we'll call that little a, is the same ratio as sine of B to side B and sine C to side C. Okay, it's a relationship between the sine of an angle and its opposite side. Okay, these are ratios, and we can put this to use and figure out what this missing side BC is. All right, I'm going to go ahead and take this ratio right here, sine B over B. Okay, and notice that angle B is 100 degrees. I already know that, and its opposite side is that diagonal that was already given, and that's 40 centimeters. Okay, so that's this ratio I can use. I also know that I'm looking for this right here, the x, which is this side here, the missing side, and its opposite angle here, we happen to know is 50. So those are the two ratios we're going to use, and we do not have to even worry about angle A and opposite side A in this case. So I know my letters don't quite match up, but I'm actually going to call this C here so I can just work with this ratio. So sine of B is the sine of my 100-degree angle. And the opposite side there is 40, given in the diagram. All right, and sine of the other angle I know, which is 50, is my unknown, the AB side, or excuse me, the BC side that we're going to call X for now. All right, let's work this out. I'm going to assume that you're going to pause the video and try this yourself, so don't just watch me do it, but you try it first. But if you're with me so far, the sine of 100 degrees is 0.9848 and so on. Let's go ahead and fill in all the numbers. And what we're going to do is we're going to go ahead and cross multiply. That's how you solve that proportion, right? All right. As you cross multiply, you're going to multiply the two numbers here and then divide by the 0.9848. It's a two-step process. And I'm hoping that you got this before I did. It should be about 31.1. I've rounded off to 1 decimal place. Back to the original question. A, draw the diagram, which we did. B, our answer we got was 31.1 centimeters, based on the law of sines ratios. C, add the second diagonal and label the intersection of the diagonals. So here it is, and we're going to label this point E. Now the thing you should know is when we draw the diagonals of a kite situation like this, especially if it's an isosceles kite, these diagonals are perpendicular. Those are all 90-degree angles in there. It just happens to be a property of this kind of shape. We also remember that this angle in here is 30 degrees. Do you remember why? Yes, in this right-hand triangle we have a 50-degree angle, 100-degree angle, and a 30-degree angle. All right. So we've done C, we have drawn the diagram and put in any information we know. Now D says the diagonals of the kite intersect at right angles, find the length of diagonal BD, correct to 3 significant figures. Let's go back to the diagram. So we need to find the length of DB from our given information. Now we know from a previous question there that this is 31.1. Okay, this side of that triangle. I also know that in this upper triangle here I have a 50-degree angle. Now I know that's 90, and I can actually figure out that that must be 40 because of course all three angles add up to 180, right? 50 plus 40 plus 90. Alright, if this entire angle here at point B is 100 and this upper one is 40, then this must be 60. Now that's going to be pretty significant because now I'm going to concentrate on this triangle right here. Alright, if I look at just this right triangle, it's getting a little bit messy, but I know that that's a right triangle right there, don't I? Alright, what I'm going to do is I'm going to take some information there and I'm going to now just use what I know about sines, cosines, and tangents and figure out this side right here, EB. If I know what EB is, I can double it and get all the way across. So I've isolated my triangle now. It's a right triangle, and I'm going to look for EB because that's going to be half of this entire diagonal. Okay? It's a right triangle, which is extremely important because now I can use sine, cosine, or tangent. I know I know all three of the angles of this triangle, and I know one side. Can I find another side? Yes. Let's go ahead and use angle B as my reference angle. Okay? Now from that angle here, the X side, or EB, is the adjacent leg of the triangle. And the 31.1 is the longest side, of course, that's the hypotenuse. So using that information, I could use this equation. The adjacent and the hypotenuse is part of the cosine ratio, right? So the adjacent leg is X, the hypotenuse is 31.1, and the definition of cosine is adjacent over hypotenuse, right? So the cosine of the angle, cosine of 60, gives us that ratio. Or what if we use a different reference angle? What if we chose this 30-degree angle down here? All right. Now, relative to that angle, 31.1 is still the hypotenuse, but now this is actually the opposite leg. So, opposite and hypotenuse would be sine. So, it would be the sine of 30 degrees would be x over 31.1. All right, either way you do it, plug the value in, find cosine of 60 or sine of 30, and then you're going to multiply by 31.1. We're going to do a little cross multiplication there and get your answer. All right, go ahead and hit pause and try that out. Now, when we finish, you get 15.55. All right, now notice how we double it, and it would be kind of a surprising answer. This whole diagonal here is 31.1. Now, I wonder why. That's 31.1 going this way, 31.1 going this way, and you know what? This also would have to be 31.1. Okay, notice here's a clue. This angle here would be 60. This angle here we know is 60, and this angle here is 60. So guess what? That's an equilateral triangle. And if we were able to recognize that earlier, we could have had a nice little shortcut there. But we use the cosine of 60 or the sine of 30 and the trig ratio. All right, thanks for watching. Have a great day. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.